Today's speaker, Dr. Anne-Marie Eldring, should be familiar to nearly everybody here. We sadly lost her to retirement on January 7th this year, but she's still, she's kept herself busy, and that's one of the things that she's going to be talking about today. So it really is a pleasure for me to turn it over to Anne-Marie, who is going to tell us this is what I've done this summer. So Anne-Marie, do you want to, can you take it over, go to full screen presentation?
Sounds good. Thank you, Mike.
For doing this.
And the feeling is mutual. I certainly miss Mike and miss all the team that we work with so closely. It's great to see all of these names on the participant list and back in the friendly crowd for sure. Yeah, I'd just like to assure you that some things change and some things stay the same. So as Mike mentioned, I retired from JPL in January and also moved to Washington, D.C. So, you know, I don't have the beautiful San Gabriel Mountains outside my window anymore, but if I tip my head the right way, I can actually see the Washington Monument, which is kind of cool. And I certainly had dreams of leaving WebEx behind when I left JPL, but the bad news is if you stay engaged, it's maybe not WebEx, but between Zoom and Blue Jeans, I'm still getting that stare at the camera tiredness like I remember so well. So good news and bad news with making a change. And yes, as Mike said, how I spent my summer vacation, I actually had the opportunity to work now on 2 different National Academy reports. And so Dwayne invited me to share our most recent release. This just became public on October 4th. So I'm going to share with you what we were asked to do, and then some of the recommendations and guidance we came up with in this report on greenhouse gas emission information for decision-making framework development. So this will take probably about a half hour to just kind of give you a summary of the key report findings and recommendations, and that should leave us time for some discussion at the end. So I'm just going to go ahead and dive in, but there will be plenty of time for discussion, I believe. So for context setting, as you know, climate is changing. The future climate depends on what we do today. Changes in greenhouse gases, and we're talking here about well-mixed greenhouse gases like carbon dioxide, methane, N2O, fluorinated materials, as well as thinking about the short-lived gases and aerosols that also have an impact on our climate and interactions with air quality, particulate matter, and ozone. Most of the writing is about these well-mixed greenhouse gases, although there is some crossover into the more short-lived gases in the thinking and the discussion that we have here. And again, just for context setting, as you're probably all well aware, temperatures have been increasing. This is a chart from NASA GIST that's showing temperature record for the average surface temperature anomalies from 1880 to 2020 timeframe. And so you see that in the last 4 decades, we're certainly above the mean, and that number continues to grow. And so we really do have an urgent need to try to address this and thwart the most disastrous impacts of climate change. And so mitigation is needed, and we know that these are key gases like carbon dioxide and methane are some of the largest contributors. And you know, through the Paris Agreement, we have efforts to start reducing emissions. Cities and businesses are actually getting really engaged these days. So there's a change also in the dynamics of who the players are in greenhouse gas reduction. But it's a complicated problem, right? We need good information about these emissions if we want to make good plans. And when we make a plan and act on it, we have to track that and understand how we're doing against our targets and our pledges. So greenhouse gas emission inventory is important for many parts of the steps that we need to take to both mitigate and assess. So this report I want to present to you today is kind of driven or motivated by a few different trends, right? It's a time right now when we have a lot of dynamic new information coming online about greenhouse gas emissions, and there's increasing demand again from everybody from corporate America to city scale, states, countries, for good information and trusted information about greenhouse gas emissions. In addition, we have new approaches, right? It's not just the same techniques for developing these inventories, but new tools, as we'll discuss further in this report. And also, there's public and private and academic players, right? This is not all done just from a government approach. And so our committee had a charge. So this is a National Academy consensus report. And so the committees are given a charge of what's the work that they're asked to do that focuses the effort. And so our approach was to describe what are the current approaches that are being used to develop anthropogenic greenhouse gas emission inventories. And including that, we might think about what those limitations were. And a prime focus was developing a framework that folks can use to evaluate this emissions inventory and information, and some guidance that might be useful for policymakers. And finally, we tried to develop some case studies to demonstrate this framework and show how it could be used to evaluate information. And to the extent possible, we were trying to identify ways that you could improve areas such as transparency, sustainability, continuity of observations. And also just note that the scales we were talking about here are not just global emission inventories, but subnational, state, and local scales. And we weren't evaluating any particular inventory or trying to address the accuracy or utility, but a more broad assessment of the landscape and the data sets that are available. And this study was supported by the Beneficus Foundation, the Heising-Simon Foundation, and the National Academy of Sciences Arthur L. Day Fund. And that's really what made that work possible. So we'd like to acknowledge those folks. So this group, there were 10 of us on the committee. Don Wubbles was the chair. I was one of the members, and here you can see the folks who spanned everything from nonprofit institutions like Gabby Dreyfus, Corporate America, Fiji George works for Cheniere Energy, a number of folks from academia, familiar names to some of you probably, like Heather Graven and Kevin Gurney and Tom Oda, Irene, and then Angel is a professor at University of North Carolina, and Kamal Bawa is a retired professor and leads a trust in India. So this was the composition of our group, bringing a number of different expertise together, and was a great crew to work with. And what else did I want to tell you? This also was, I don't think I have a slide on it, but just for knowledge of your timeline, this is what they call a fast track study. And we actually were called in May and asked if we could participate. We had a first in-person meeting in June and spent the rest of June and July drafting the report. And by August, it was out for review. And late in August, we replied to the comments. So there's a very rapid turnaround. So you'll see the level of detail is sort of fitting with the speed of which we created this report. So let me dive in now to some of the more technical work. So what do we mean when we talk about greenhouse gas emissions inventories? So there's different approaches, and I'll describe these in a little bit more detail in the slides that follow, like activity-based, atmospheric-based, and hybrid. And folks like policymakers need to understand what the emissions are, and the activity-based is a approach that you'll see is very familiar to many folks, particularly in the regulatory community. And the atmospheric-based approaches are a little bit more from the research community, while hybrid approaches are a more recent development, but they have a lot of potential given their characteristics. There's already a large amount of information available on emissions inventory. We'll talk a little bit about the tools that are used to develop those. So activity-based approaches, what are we describing here? This is when you have information about activity like traffic or production statistics or fuel consumption. And then you have some other information about what typical emissions are, how much greenhouse gas is emitted per volume of, say, natural gas in a pipeline, or per fuel burn, or per vegetation grown. And you use these two numbers to make an estimate of the overall emissions. And this is also very widely used, as I mentioned, in regulatory community, and the United Nations, the UNFCCC, uses this type of process to develop the emission inventories that are currently part of the reporting process for the Paris Agreement. So it's a very widely used approach for estimating emissions. So that's activity-based. And then if we look at, as I mentioned, there's a lot of this type of information already available, everything from country scale to more local scale. So just for example, these are UNFCCC, the EDGAR, the CDAC are all country level scale emission inventories. And then you have other things such as GRACE and ODIAC that are at a smaller scale, like a much finer grid, and much of this is also used in the research community. So we have activity-based approaches, and then atmospheric-based approaches are where we're bringing in other measurement data, could be from ground-based instrumentation, aircraft, satellite. Often an estimate of emissions from activity-based work is included, and then brought in a model system that accounts for transport, mixing, removal processes, and all of this information is integrated to try to create a more complete estimate of emissions. And this is an approach you may be more familiar with in some of the work that you are involved in or see done at JPL. So the third one we're going to talk about here is the hybrid approach. So the idea here is that you, in a more holistic or integrated way, are bringing together that activity data, atmospheric data, emissions information, and we talk about non-traditional data. This might be, say, information collected through mobile phones about traffic density and traffic counts, or inferences made from imagery, satellite imagery data about building density. So other ways of trying to get at the factors that are important. And then this may be integrated, again, with transport atmospheric models, but perhaps machine learning is applied or other new tools to try to transform this into emissions information. And again, this puzzle might be put together in many different ways. These are just, consider these the ingredients in the idea, and an actual hybrid system might only have a portion of these tools utilized in it. So those are the three approaches that we're going to talk about as we discuss this topic. Now, when folks had a discussion in our meetings about what's wrong with what we have today? What are the limitations? What are some of the difficulties of the type of data that we have? And a few of the ones that came to the top were issues such as the structure of our institutions. This type of inventory information is really located in many different repositories. It can be difficult to find and difficult to bring together into one place. With activity-based approaches, there's also the difficulty of what's the quality of that underlying data. Sometimes it's quite dated, or it may not be representative. An emission factor is developed in one country, but the technology used elsewhere is different, and so that is not a useful factor. For atmospheric-based approaches, some of the difficulties are when this is really in the research arena, those measurements may be not continuous, or they have different types of information. Transport models have errors, and one of the real issues here is the difficulty to separate emission sources. If you measure methane in the atmosphere, that doesn't tell you if it came from agriculture or landfill. You need some additional information to try to link it back to the key sources. And these hybrid approaches are new and definitely have some characteristics you don't find in the other ones, but there's still issues of transparency of the data, understanding data quality, understanding the algorithms within them. So there's certainly no silver bullet with this work, but different strengths and weaknesses of the different approaches. And so in reviewing that, we came up with a group of what we called pillars, or a common framework to help us evaluate greenhouse gas emissions and inventories. And so those are summarized briefly on this slide. So the first one we identified was usability and timeliness. So we really want information to be useful on the timescales of decision making, right? If the industry is rapidly developing, it's not that useful to have information that's 5 years old. You need something more current to understand the current activities. And it needs to be comparable and useful for these decision makers. Transparency we saw as a very, very important characteristics. We think trust in information really is aided by transparency. And so this means publicly available, understanding the ingredients or the background information that went into the final data product, and that information is traceable. And not surprisingly, evaluation and validation was an important pillar. If folks put together an inventory and provide information, there has to be some review and assessment that's done at the lower level so that there's some understanding of what the quality and the uncertainty of the data sets are. And of course, for the big picture of policy making, completeness is important. And here we're referring to, are all the greenhouse gases included in the inventory, all the sectors there, and does it cover space and time relevant for the decision making? Inclusivity is also a feature we thought was important. And this is the idea that who's involved in creating this information, who's thought about as the information is created, are we engaging all of the stakeholders in the development of the greenhouse gas information? And finally, communication, that the information is described in a way that's useful and understandable. It's openly accessible, it's well documented, that the end users can get the details that they need readily on this information. So we developed these 6 pillars, and then as you see, we're going to do some assessment about how the various approaches and data sets comply with the pillars that we've outlined. So this is just the high-level summary. You'll find a lot more details in the report. And what we did here was we, as a committee, looked at the different approaches, activity-based, atmospheric, and hybrid, and looked at our pillars, and we came up with sort of a consensus evaluation of how the methods and the data of the different approaches conform with the pillars. So this is, meant to be, it's not a detailed analysis of 10 different data sets. It is, by and large, for this approach, does it meet the pillar or not? And we also use sort of, we call it the tough love approach. So if something was a little bit between the low and the medium score in our minds, we would write down a low as a way to sort of say, hey, this is an area where things could be improved. And what you see here is, there's areas like inclusivity that we deemed almost that all the approaches and the methods really did not comply very well with the inclusivity, whereas something like transparency of the information, there's some areas where it's actually very high transparency, while some of these newer methods have not yet reached that high transparency. So we created this scoring, and we have discussion in the report if you want more detail about why that was and what some of the key influencing factors were for the different areas. And also a few other thoughts about when we apply this framework. You know, this was difficult to do because we were talking about everything from city scales to national scales. And we were also trying to think about not just as like a technical information provider, but what about the perspective of a policymaker? So trying to think about the evaluation of those greenhouse gases in the context of what the intended purpose was. You know, is the purpose for the data also described and communicated? Is it developed to be usable for that purpose? Does it have the quality and accuracy for these purposes? And in the report, we looked at some case studies in detail. So here we tried to get to the specifics. Like we looked at the UNFCCC process and how well does that process meet the pillars. We looked at, for example, the influx experiment in Indianapolis. It's a very different goal, a very different scale, and we tried to talk about how that met the pillars. And so we couldn't do case studies for everything that exists, but there's sort of a half a dozen in the report where we talked about that and tried to be a little bit more concrete about how these pillars could apply to the development of the greenhouse gas information products. And I think at this point, we're gonna do one more context setting and then dive into the recommendations. So this slide also was just trying to remind you about the bigger context of things, that these pillars are meant to be used, you know, in the context of this iterative activity, right? So what happens when you make a greenhouse gas inventory? It doesn't just get done and then put on the shelf, right? The idea is that that will then feed into people who are trying to make decisions, trying to plan, tracking how they're performing, assessing and verifying that the changes they're making are having the needed impact. And that, you know, feeds into this broader policy goal of mitigating greenhouse gases and responding to climate change. So these pillars can be applied, and some of them will be more important in some different parts of the activities, right? While you're in the midst of developing your greenhouse gas inventory, things, for example, like evaluation and validation and completeness might really be the most important pillar to think about. Whereas in the decision phases, perhaps it's communication and inclusivity. So the pillars vary in their utility, and also think about the fact that these are about data. These pillars are also about institutions, and they're about processes. So they apply to sort of all the steps and players inside of the creation of greenhouse gas emission inventory. So now I'm going to turn to the actual concrete recommendations that were made in the report. And the first one is just that greenhouse gas emission inventory development and evaluation work should strive to align to these pillars. So think about the pillars as you're doing this work, and try to make some assessment about performance and improvement as you iterate through processes to create greenhouse gas emission inventory. So that's kind of the apple pie recommendation. And then some more detailed recommendations. One that we made was about a clearinghouse. So we really had a lot of discussion about the difficulty of finding information and comparing information. And we think that some sort of a coordinated repository would really be valuable for this work. And we were careful to use the word here, a federation of repository or coordinated, meaning it doesn't have to be one centralized clearinghouse, but just some method of having data located in the same place with same characteristics that would improve usability. And some of the characteristics are listed here. I'm not going to read through all of this, but you know, we really felt like this approach could improve the traceability of the information, and definitely the standardization of data could be enforced through a repository approach. Even like evaluation metrics, whether qualitative or quantitative, would be encouraged in a repository. And, you know, you could design it such that capacity building and education are also addressed with this. And one thing we wanted to note is that we're not saying every effort that exists should be thrown aside for this new repository, but we should build on some of the institution and tools we have. And we should learn from other areas like air quality and meteorological communities, particularly the meteorological community has a lot of international close collaboration and information sharing. And perhaps those are some templates we could build on for the greenhouse gas emission inventory work. So this clearinghouse or coordinated repository was a key recommendation. And then here we're in a little bit more detail about different areas like the transparency, right? That the greenhouse gas emission inventory development should be transparent, trying to communicate what the underlying data is. And again, through this repository, some of that structure could be developed and enforced. And we do sincerely believe that if the more transparent and well documented, the more this data could be trusted and relied on by various actors. And granularity is another area we thought it was important to make a recommendation. Again, the national scale is not the only scale that's important, but we see a lot of work happening now at local, urban, city, even facility levels. So work to bring that greenhouse gas information to that finer granular scale and temporally and spatially, we thought was really important. And again, let me just check on my notes here. One of the other areas is, yeah, a lot of the emission factors come from one part of the world, but should be more representative of other areas. And this is in the accuracy and representativeness. Emission factors should be appropriate for the areas they're being used, and similarly activity data. So again, we can't just rely on one global number, but this needs to be tailored for the regions that we're working with. And a recommendation that may be of interest to folks at JPL is this one about operationalizing. And here when we were discussing especially the atmospheric-based estimation approaches, we felt there's a lot of work happening in the research community, advances that are occurring through various investigations, but yet it can take a very long time until this is brought into a venue where policymakers can really take advantage of it, or it can be used widely for addressing emissions inventory information across the globe. So finding a way to really bring this transition along, bring findings and tools from the research community into a broader usefulness in our different institutions is an important step. And again, this can also address the timeliness and the sort of age of information. If we have these tools working in a more operational way, the information can stay a little bit fresher. And in line with that, we made a recommendation about the hybrid approach. So our assessment was that we really should strive to quickly advance hybrid approaches and integrate these into the tools that are being used readily. And we see that there's a lot of potential because in some ways the hybrid approach integrates the atmospheric and the activity approaches. It tries to use the most optimal systems to use that information, analyze that information, make inferences from that information. And we see work in areas like the meteorological and air quality community of data fusion, data assimilation, and machine learning. And these certainly point to a lot of benefits from these more advanced approaches. And we thought hybrid, you sort of have weaknesses in activity data approaches, weaknesses in atmospheric, and you maybe minimize the weaknesses when you integrate the two. And also, there's a lot of new work and certainly technical problems to solve, but we think there's a lot of potential with this as well. And finally, the idea that this information people generate is used inside of a decision-making iterative process, it's important to reduce the isolation of the activities, right? So get decision makers, stakeholders, technical analysts to be engaged with each other, understand what the needs are, what's successful, what the remaining questions are, and really try to work in a more integrated and iterative manner than we typically do today. And, you know, the more we can do this, we can probably reduce the timelines of new information and also facilitate investments in systems that support an iterative process. Perhaps that should be a goal of the repository that we discussed. So that's where I'm going to end with recommendations, and just also, you know, a little comment on what we've talked about or presented here today. Is we know this is not answering all the questions or laying out the definitive set of tools, but we try to really assess current state of affairs, make some suggestions about where we should move in the future, and really try to push the conversation forward. There's a lot of opportunities. It's, again, a very exciting state of affairs right now with people interested in this work, not just the government, but universities, the commercial sector, new instrumentation, new information, advances in computing, and new techniques. So there's a lot of ingredients that are changing, and we should really work to utilize all of that and improve and update the greenhouse gas information that we have. So hopefully this is a little bit of a spark for that conversation. So I'm going to stop talking. If you want to read the full report, you can go ahead to nap.edu and download the PDF there. So thanks for your attention, and look forward to having some back and forth in our Q&A now. Thanks.
Thank you so much, Anne-Marie. I know there's some questions in the chat, and while I fiddle here, there we go. I'm going to ask, I know Dwayne had posted a couple of questions. I'm going to invite Dwayne to ask them first. And
sure, now. So Anne-Marie, thanks. That was great. I had two questions. One is, you yourself, did you learn anything about the pull for greenhouse gas information that was new to you and going through this study and meeting these people? You know, kind of with the U.S. government in mind, does there seem more pull for that, or other actors? That's the first question.
Yeah, it's an interesting question, Dwayne. I think in doing this work, I think it just confirmed what I had already kind of understood about the EPA's work and the feed into the UNFCCC process. But what it did highlight is the interest from so many other areas, like especially I think corporate America has gotten pretty engaged, and they have need for good information as they try to make decisions and understand their own business. There's the whole discussion about the SEC and scope 1, scope 2, scope 3, and this idea that corporations may have to report some new information about their greenhouse gas emissions in the future is a whole new arena. And then I think in the area of the states, you know, I kind of was aware from the research community about some activities, but we got to speak to some folks who work for, like example, the state of Colorado, state of California, and understand the level of activity, which I think the work at the state level is more than I had really understood. So there's this idea that it's not just the country's total emissions, but there's a lot of interest in all these different levels. And, you know, as you probably are aware, the states are making climate action plans. So in true U.S. style, it's not really happening at the federal government necessarily, but it can be happening at other levels of government.
Thank you. My second question is, I got the impression in that Basque meeting that we were both in that really the pull for this, despite who sponsored it, was probably OSTP or something like that. Some level of government above the agencies was really the thing that was pushing on getting this study done, and maybe for an interest of inserting into the conversation at COP. Did you get any sense of that you could elaborate on?
Yeah, no, I think you're definitely right that the timing was largely driven by an interest in being ready with some recommendations before the COP27 meeting. And I think you're right that this is, there's the Office of Science Technology Policy, and also these, there's a new interagency working group, and I think that those parties are definitely interested. Right. This wasn't like the EPA saying, hey, help us out here, but it was a much higher level federal effort. And it also in that context of the new activity from private entities and companies that are getting into greenhouse gas measurements and greenhouse gas activity estimates, et cetera. So there's kind of a new arena of players, and I think that was another aspect that motivated doing this work.
Thank you. There was one other question in the chat before I turn it into the room, because I think Randy's got a question that I noticed. Okay, so there's several. All right. So, John, you posted a question in the chat. Would you like to ask that question?
Yeah, sure. I have a couple questions. Hi, Amory. It's good to see you and good to hear your voice again. Definitely miss you. So the question I had is, when you were developing the pillars, it seemed like you were giving different weights to different ways to quantify emissions. The prior uncertainties, though, and information content of those different approaches vary, considerably across the globe. So how did that come into play when you were developing the concepts for those pillars? Sorry, my dog is barking.
Yeah, no, I have to admit, John, you're going to be disappointed to hear it, but we did not actually ever say information content to each other when we were doing this work. No, I think because it was done at a pretty high level. Our assessment of the performance against the pillars was, really done kind of in broad strokes, and only in the case studies did we get a little bit more into the details. And so things, like the information completeness or all the sectors included, those were things we talked about. The area of uncertainty of the data almost felt like it could have driven a whole nother report. And I think if you wanted to develop an implementation plan for what the next step should be, or a research agenda, there's a whole bunch of more work that would have to be done to kind of bring it down to that level of detail. And when I think about the type of work that you do, or Kevin and others at JPL with the analysis of the data that we collect, I think that's where this iteration is useful, right? Because we have a framework where we think about, what's the quality that I need, or what's the characteristics I have to evaluate. But I think some of the conversations we had with the policymakers is like, some questions, they're still really just looking for better quality information than they have. And some of the level of detail that we worry about is not even on their radar for the kind of work that they need to do. So I think that's area where we probably would benefit from kind of having some more conversation with potential users of the data, if it's not just the research community.
John, one last question.
I didn't quite understand what you meant by a hybrid approach.
Yeah, so if I was trying to describe that, you might think of, I think some of the work you're already doing, or some of the work we see from colleagues, where you start with an emission estimate from a bottom-up inventory. You have atmospheric observations, whether they be ground-based aircraft, satellite. You use a transport model, and then you basically try to optimize this system, right? So you're adjusting the emissions based on trying to match the atmospheric observations with what your
okay,
model.
I guess I would have thought that would be the atmospheric approach, not the
Yeah, I mean, we had long conversations about what's atmospheric and what's
gotcha.
What's hybrid. And I think there's some class of work where people basically take observations and infer emissions without an optimization in the way you do. And so that is more what we were talking about with the atmospheric approach.
Okay,
Yeah.
thanks for clarifying that.
So in the room, there's some eager questions here, and there's now 4 in waiting. So I'm going to run this anti-clockwise. Randy, can you, yeah, you know the drill.
Yeah, hi, Anne Marie. My ultimate question is going to be to you, what should NASA do with this recommendation? Okay, but to seed that for you, I want to say that there's 2 recommendations that I think would confuse NASA. So the first is you say operationalize. They got to hurry. So in some sense, NASA would say, well, that's not really what we do. But on the other hand, you say we should really pursue a more full hybrid approach. Now, then following up John's question, when I think of hybrid, I usually think that you've got already your sort of standard approach that people use. And when you say hybrid, it usually means that you've got to like go beyond the standard approach with something that's new. So operationalize and do something new, or at least on surface level, contradictory. What's your thoughts about that as it ultimately comes back to what should NASA do with your recommendation?
Wow, Randy, you expect me to have a lot of information, but let me do my best here. So I'll start with your second question of what's hybrid, perhaps versus what we're doing. And I think some examples of what we see as new ways of doing this work that make it this hybrid model in our minds is, for example, there's folks, again, trying to use satellite imagery data to then make inferences about, say, ship activity or traffic or building density, et cetera, et cetera. So they're kind of using new measurement data to make inferences about information they need in a way we didn't used to do. And sometimes this involves machine learning, and sometimes this involves sort of estimates of a signal you can measure and the quantity you're interested in. So they're potentially can add a lot of information, but as you say, there's still some untested ideas in that. So if I was trying to figure out how to operationalize, I would probably, take something that's a bit more mature and try to think about, well, how can the agencies that have responsibility, whether it be a state or the EPA, is there a way we can create either work with them to create information that meets their needs, or build tools that they can then integrate into the processes they use. And I know that sounds difficult to do, but we certainly, the weather community is somewhere where we're like, well, people used to do this transport modeling more as a research activity, and then that got matured into something that created forecast, and then even digest those forecasts into information you can just look up on your phone. So how can you get that kind of a process rolling quickly with greenhouse gases so we can have emission inventories that become easier to generate and more timely? And what's NASA's role in this? I think there's 2 areas. One, I would say, what do we learn from the measurements we make? Is that information then getting integrated into the nation's plan for operational measurements? And I know that's a really, really slow process, but we do see some characteristics, say, of Landsat satellites that have changed as we move into this new era. So there's, we may, that's a longer time frame to influence what measurements get taken. In a shorter time frame is even just getting folks out there talking to more than just the research community about what is it that we collect from the satellites, how might it fit into the tools that they use. And then I am convinced, and this is a little bit more of my own opinion than the report recommendations, Randy, but the work that needs to get done isn't just NASA, right? It's NASA, NOAA, EPA, and a number of federal agencies. So how do we work with our leadership to work with these agencies and really try to do that stuff in a more integrated way? Because it's not just measurements, it's not just model building, it's all the pieces working together and becoming a little bit more sophisticated than an individual activity has led us to now. So I don't know, that wasn't a very short answer. I think, what's the magic wand that NASA needs to wave? It's maybe working closely with some of the other agencies, and then also really, really pushing to make sure people understand the data that we've collect and what the potential utility of it is in the activities they're doing.
Yeah, no, thanks for your thoughts about that.
All right, Dave, you had a question, and I see Kimberly online as well. So those will be the two. There you go. You're up. You're up.
Yay, here we go. So, Anne-Marie, I think it's really important for the different environmental science and management areas to learn from each other. But I also think it's important to understand what some of the differences are. And, air quality is often the model that we look to, whether it be urban air quality or the stratospheric ozone hole. And there are definitely a lot of lessons in common, but there's one difference, and I wonder if it is going to become more and more important. So for air quality and ozone, we have these kind of titration reactions where you want to reduce certain constituents and potentially increase other constituents. But in general, you're kind of playing with ratios of things. But with CO2 in particular, the right answer is actually zero, right? When you look at the implications of the AR6 and look a little past Paris, what we're really pushing to are to reduce fossil emissions, not to some level that's consistent with, something like acceptable ozone levels, like non-exceedant levels. We're actually pushing to reduce fossil emissions to zero. And at the same time, we have to understand what that's going to do to the natural sinks. And we really have no observational information about how sinks are going to behave or stocks, for that matter, in a world where concentrations aren't increasing, because those sinks have been created by each year having a higher concentration than the previous year, especially the ocean. And I wonder if anyone discussed the fact that we're really looking for an observing system that's not going to help people during the transition. I mean, it will, negotiate, we'll pull things down faster here, we'll pull things down slower there. But with like ozone precursors, you're sort of saying, well, I'll take mine down low so you can still continue to emit a little bit. But with CO2, eventually everybody has to go to zero. And it seems to me that that's actually a really different problem than the models that people have in their minds. And at least in my mind, it's just becoming clear to me how different that really is from the kind of emission trading models that California is very taken with. Because eventually there isn't going to be anything left to trade, right? You're trying to get people to trade down to zero.
Yeah. Right.
Not to some stable market. You actually are trying to make the whole market go away.
Right.
And pretty quickly, if you look at the 2.0 requirements.
So I think Dave just made a statement for the next National Academy study. But
thank you, Mike. That's where I was gonna go. I mean, I think, Dave, this was I don't think I emphasized it, but the request for this report was focused on anthropogenic. And so we really weren't able to get our hands around also the natural system part of it. And totally, Mike, our comment to ourselves, and I think there's a line in the report, there should be another report about this, but I think, we really were actually on a time frame much shorter in our thinking, right? This is like the next decade, but you're right, Dave, we should be, how do you think about this if you're really trying to talk about 20 years
net
zero?
Net zero to stabilize at 2 degrees isn't a whole lot longer than a decade.
Yeah.
It's only
No.
2 decades.
Anyway, I'm going to just keep an eye on the time. Kimberly, you posted a comment or question in chat. Would you like to ask it?
Yeah, thanks. Hi, everyone. Hi, Anne-Marie. This is Kimberly Miner. Great to hear your talk. Thank you so much for being here. I've also been thinking a lot about earth science data across a variety of scales, but including greenhouse gases, and how to make some of that data more applicable, more operational, just more usable by regional communities and local, be it whether state or community on a smaller scale level policymakers. And I wanted to see if you could just elaborate just a little bit. I know we have a little bit of time, but we could also take it offline.
Yeah. I mean, I think, Kimberly, that's a really interesting question. Through this work, I met people from agencies like the Colorado state agencies. You probably already know the California state agencies, but then there's even folks at city levels in Baltimore that we interacted with. I think, in short, there's folks out there, but it probably requires some new outreach or finding. I haven't figured out if there's a meeting they all show up at. And probably the risk here is the numbers multiply so quickly, right? When you get to the state level, you already got 50, and now you want to go down to cities, it's a heck of a lot more. But they're definitely out there in some agencies. And I'm not, I'd have to think about how you start making those phone calls.
Quite right. So another key. No, it's not on. Look for the little button, the speaker button.
Oh,
There you go.
Hi, Anne-Marie. This is Sudhanshu Pandey. I was looking forward to have you here in person and then have like a much longer discussion with you about what you were talking. But now, okay, I'll put the strongest point which came to my mind. And so you say like their completeness and then all the things they need to happen at a lot of levels to get this information. The alternative can be, which we know more from this methane world, and also the picture you showed of a plume coming out of a landfill, I think it was, and then the last one was a power plant. So in terms of implementation, in terms of gains of reducing emissions, one, and the other one is to monitor these emissions using surface or satellite data. These are the easier targets. So when we do focus on these, we are not being complete, but it makes the job much easier. So how would you weigh in these two different approaches to handle this?
Yeah, that's a good question, Sudhanshu. I think, this is where we were talking about sort of fit for purpose. So if you were, say, an energy producer and you really want to understand your facility's production, then completeness for you doesn't probably care about fluorinated gases, or, N2O is not really something you emit. So you're going to think about the gases you emit and then the scope of the facility that you have. So I think some of these analyses and measurements are helpful for that kind of activity, and also for again, states probably have action plans that are focused on particular gases rather than the whole kit and caboodle. I think the completeness and including all of the greenhouse gases really comes into play when you're thinking about the global picture and the total radiative budget. And so if that's the problem you're trying to solve, then certainly you need to be able to address all of the radiative forcing gases. So I think some of the kind of work you've been focused on that's methane focused certainly has an arena to be useful, particularly more, to my mind, it seems to be the business communities and state level agencies that are really thinking about methane in particular, and the leverage we can get off of controlling methane and quickly reducing it to address greenhouse gases.
Okay, thank you, Anne-Marie. Online, Stan, would you like to ask your question?
Yeah, thank you. Hi, Anne-Marie. It's good to see you. So I wonder if your committee considered a very concrete case among its case studies. So in California, we have legislation that requires carbon emissions to decrease at certain target dates. But the issue is, for example, for methane, the state agencies rely on the utilities to provide bottom-up estimates of emissions. And there are not very many long-term monitoring systems for verification, but there are some. And at least in the case of the one I'm thinking about, the bottom up and the top down do not agree by significant factors. And so I was wondering if the report considers cases like this, because I'm sure this is not unusual or will not be unusual when the
Right.
data records become longer term.
Right. That's a good question, Stan. I mean, I think we have a little bit where we talk about one of the positive cases in this regard, right? When you look at the fluorinated gases and the global measurements didn't agree with the global emission estimates. And so then some, I think, action was taken or reductions were made, and you saw that show up in the observations as time progressed. But the question you ask about states and the way they rely on reported activity, that's, I think partly what drives us with this idea of iterative activity work, because certainly the atmospheric based observations are in disagreement with the activity. You want the regulator to know that and to be able to then respond to that. And you do, when you talk to the EPA, you hear some concrete cases where they've done that. State of Colorado is certainly trying to ingest what they're hearing from research community and then go back and work with their emitters. But that is a little bit of a slow and inefficient cycle. But definitely, I think the state of California understands the value of bringing in that observational data. But as you say, the observations are limited. But I think the future's going to change, right? You have tropomi now, but GHG sat, carbon mapper, methane sat on the future. There's a lot of new data that's probably going to shine a light on some of this question. And I think the more the regulatory community is familiar with what we're doing and what we're inferring, the more they'll be willing to trust that information and try to utilize it in their processes.
Thank you so much. Now, with an eye to the time, I think I'm going to draw this to a close so we can thank Anne-Marie one more time. That was fantastic. Thank you, Anne-Marie.
And feel free to email me with follow-up, and please take a look at the National Academy page and take a look at the report. Thanks for inviting me. I think Dwayne had to step out, but I appreciate your excitement and enthusiasm to have me back.
Oh, every time. So next summer project, we'll have you back. Thanks, everybody.
All right.
Bye.
Thanks, folks. Bye-bye.